Welcome. This question says, consider a sample of ideal gas of helium at 100 degrees C, and the mass of helium atom is given as 6.7 times 10 to the minus 24 grams. Show that the resulting gas speed is 1,529 meters per second, which is about 3,300 miles per hour. So let's visualize first of all. We have a little volume, and inside this volume, what do we know about it? Well, we know that its temperature is equal to 100 degrees C plus 273 Kelvin. And then we know the mass of the particles is 6.7 times 10 to the minus 24 grams, means 27 kilograms. And we know Boltzmann's constant, and we've got to find the rest out. So no equation immediately comes to mind, but I know that PV equals number of particles, big N, KB times T. And I also know that P is equal to 2/3 N over V times a half M velocity squared. So if I rearrange the second one, I get PV is equal to 2/3 N times 1/2 M average velocity squared, and these two can be put together, so I end up with N KB times T from the top, and equals this from the bottom. 2/3 N 1/2 M average velocity squared. Well, the 2's are going to go away, and I want to find the speed, so let's rearrange. So V squared is equal to N KB times T, and then that 3 goes to the other side and goes on top, and that N goes to the other side and goes underneath, and the M is underneath. So this means that V is equal to the square root of 3 KB T over M. So V is equal to the square root of 3 times 1.4 times 10 to the minus 23 times 373, 273 plus 100, divided by the mass, and the mass is 6.7 times 10 to the minus 27. So V is equal to, so let's get my calculator, and I go 3 times 1.4 second e to the minus 23 equals times 373 equals divided by 6.7 second e to the minus 27 equals, and then second square root, second answer, and so I get 1,529 meters per second. Meters per second because I'm in SI units. So that's the first part. And then just as a little aside, well, let's convert 1,529 meters every 1 second, that's a meter per second. And I don't want seconds, I want miles per hour, so I want hours to go on the bottom, which means seconds has to go on top. And 1 hour consists of 60 minutes, and each minute consists of 60 seconds, so it's 60 times 60. So now I've got rid of my seconds, and then the next conversion I can do is I can say, well, I don't want meters on top, I want kilometers, so kilometers and meters, and 1 kilometer is 1,000 meters. So now I've got kilometers per hour, and then my final conversion is that I want miles on top, I want kilometers on bottom, and 1 kilometer is 0.6 miles. So when I do this, I go 1529 times 60 times 60, enter, times 0.6, enter, and then divide that by 1000. And I get, yeah, so V is equal to 3302 miles per hour. So there's my 2 answers. This is just a great excuse for throwing numbers that aren't appropriate at you. You can learn the final equation, but I find it much easier. I already know N PV equals N kBT, and I already know that P equals 2/3 N over V times 1/2 mv squared. So why learn another equation? Why not just get used to combining those two? And the answer will just take care of itself. So there we have it.